My name's Rick Riss, and this is the story about designing and building a net zero house. It's not only net zero, but it's built to the German passive house standard. So we achieved net zero by a very efficient building for a house that inherently uses very little power. I hope you enjoy it.
My wife Claudia and I were looking for a piece of property that had a good view in a rural New England location and suitable to build a house. In the spring of 2005, our best man David Conway was killed in an avalanche at Arapahoe Basin ski area in Colorado. It brought the reality that life is short, and I decided that building a net zero house was going to become a goal of mine. David and I had done a number of building projects together, and this time I wanted to build a house that was on the leading edge of efficiency, that is powered by sunlight, and that was well suited to our local New England climate. Claudia found a listing for a 6.7-acre lot on Mountain Road in Princeton. We could see the potential for a great view in a small rural town that has no stoplights and no gas stations. We worked with our realtor, Chris Casucci, to buy it from a Japanese doctor and his brother who had lived in Worcester. The property is very steep and located on the east side of Mount Little Wachusett with a view to Boston. It took us a few years to figure out what to build. To start, we removed the guardrail and brought in enough fill just to park a car. The steep slope meant that this construction would need a lot of attention to drainage and water management. Our first project was to deal with the 15-inch culvert that dumped lots of water after every rainstorm. So we added a collection system, a manhole, and a 1,500-gallon cistern. Located at the top of the hill, we used the cistern as a gravity-fed garden water supply, so it's now become a resource instead of a problem. Any excess water is diverted to a safe location. The first idea was for a geothermal heating system after I watched a Mansfield neighbor install a system in an old Victorian house. A crew from Louisiana came up and drilled 4 wells at a cost of over $30,000. And even that size system was marginal for this big and poorly insulated house. So my idea was to build with enough insulation to use maybe only 1 well. After some MathCAD building calculations, I began to realize that once you build a super insulated shell, you will really need to focus on high quality doors and windows to avoid excessive heat loss. So that led me to passive house windows and a German passive house design method. Once I learned about the well-tested building physics of the passive house method, I abandoned my MathCAD models. In retrospect, it was a very good idea. With a 3-level house, we built the top 2 levels to form the passive house envelope, and the bottom level, sunroom, was a separate but well-insulated space. The passive house method is a tedious effort with incredibly more detail than I would have imagined in my MathCAD house models. The goals for this house were documented in a functional requirement specification. The idea is to figure out what's important and to make sure at the end of the project we minimize the "I wish I had thought about that at the beginning" type of scenario. There was only one main function we had to give up on, and that was driving into a protected space at kitchen level to unload groceries. Turns out, in decent weather, we stop at the top of the driveway if there's a lot to bring into the kitchen. Otherwise, we just drive down into the garage and need to carry a few groceries upstairs, but at least it is all out of the weather. So I found an architect that had built most of the early passive houses in Massachusetts. That's Steve Bassick. Steve relied on passive house experts, and I hired an experienced passive house consultant, Mike Duclos, who worked with Steve. This unique pairing of the 3 of us required numerous design reviews and decisions to iterate on a proper envelope, windows, their exact position, the doors, insulation, overhangs, HRV, and efficient appliances. It was a dedicated effort to correctly prepare the passive house spreadsheet and ensure it was synchronized with the emerging design. I visited Dan Roy's house in Falmouth, which was in construction as my project was still in design. Dan is a very capable engineer and ultimately became a certified passive house consultant and proved very helpful for my project. And we remain good friends to this day. Steve Bassick and Mike Duclos were both aware of that house. Steve Bassick designed the house for Dan. The passive house method is a rigorous and proven building physics method, and that really appealed to engineers like myself. While it looked like this project would have met the Mass Save Tier 3 requirements for a big tax credit, the town of Princeton does not participate with the Mass Save program, so there was no economic benefit to pay for the inspections needed to get passive house certification. However, I still ended up faithfully designing and building to the passive house standard and did achieve a HERS rating of -2. A HERS rating of 100 is average for a new house, and a HERS of 0 is a net zero house. With the design in hand, I found an experienced contractor, Brian Del Maso, from BMK Associates, and Brian brought many skilled contractors to site, but he let me manage some of the contractors, and Brian and I split the work. I handled the design, the heat recovery ventilator, the footbridge, the heat pump, the water well, the insulation, and all the site work. My son Jeremy did all the tile work and helped me install the HRV and central vac. BMK handled the foundation, framing, electrical, plumbing, the sheetrock, roofing, siding, floors, and all the finish work. We both worked on extensively sealing air leaks in the house. Then there was Paul and Walter Yanowicz, my excavator. They were the most expensive contractor, but critical to the success of the project. They were on site with all the big equipment needed for the duration of the project. Walter and Paul built the roads to facilitate well drilling, the roads so we could get cement trucks in and pour the foundation without the need for a pump truck. They enabled the construction crews, built the culvert, built the cistern system, built the geoflow septic system, provided French drains, installed the geothermal slinky loop, installed the underground electrical service piping. In addition, they built extensive stone walls and covered slopes with stone to protect against erosion. They were on site and needed throughout the whole project. Claudia designed the kitchen with an inductive cooktop, 2 wall ovens, a convection microwave, and with extra cabinet storage to take advantage of the 10-foot ceilings. There were a lot of subtle design features, such as the careful selection of paint colors to get diffuse natural lighting, the intercom system, the really cool Arduino stair lights that my son John programmed, the video camera with a DVR recorder, home entertainment that was very clean system, getting rid of the old receivers and just using a sound bar, a fiber internet connection with a home network providing plenty of Cat 5 and 6 outlets, also with Wi-Fi throughout the house, 3 different EV charging outlets, window shades, a metal roof with snow slide protection, and Claudia really likes the window boxes on the footbridge that my brother Tim fashioned from leftover AZEC planks. Overall, it did work out, and like magic, the passive house heats and cools on almost nothing. It is amazing to see how little mechanical assistance the house needs to stay comfortable. Compared to any other house I've ever lived in, this house is just naturally at the right temperature and humidity. We moved in during the last week of December 2016. In December 2017, we added an 8 kilowatt solar PV system with sun power panels and a Pica off-grid inverter. The roof was actually sized for these specific panels so they would fit neatly on the roof with a minimal overhang. Without net metering, the first year we gave away about 50% of all of our solar power. But once we got a Tesla Model 3 in November 2018, we found we could charge during sunny days, so that cut my exported power to about 16%. This makes adding batteries to our solar system not very economical. We use the battery in the Tesla. With 6.7 acres of mostly woodlot, we are now a net carbon sequestering family, and while we still have one fossil-powered car, that should go electric in a year or two, most likely a Tesla Model Y. I doubt we ever get to 100% fossil-free, as my little Kubota diesel tractor is my right-hand man for yard work and snow clearing, and we do have a propane grill and a few gasoline-powered yard tools. Hope you enjoyed the presentation of my passive house.